Hello and welcome back. We have understood a little bit about the data frames and the visualization. Now let us try to understand a little more about adding columns, dropping columns, and then trying to manipulate nulls and other stuff. So to add a new column on a data frame, we can actually take the data frame object and specify the column name and equate the value like this. A list of values at 20 values, because the data frame size is 20. I need to definitely pass 20 values here. So I have passed the 20 values. College is the column I'm trying to create. So when I do that, what happens? Let us see. See that it got added a new column. If you try to see the whole data frame also, you will see the college names there. And now if you want to remove a column, here in some cases the unnecessary columns may be there present in the data set. So you may have to drop the columns. To drop the column, we have a method called drop in data frame, and you need to specify the column name. Let us see what happens if you remove these two attributes here, the axis and in place true. So I have taken out those two and trying to execute this. It actually throws error saying that not found in axis. Now whatever the column we have specified, whatever the string we have specified is not found in the axis. By default, in drop method, the axis is going to be 0. That means rows. So it is trying to find std hash in the row index. By default, when you create a data frame, the row indexes are integers. If you see this, the row indexes are integers 0, 1, 2, 3, and it is trying to find the drop method is trying to find the stored hash in the row index. So to specify that drop method need to look into the columns, we need to specify axis is equal to 1. Axis is equal to 1 means columns. So now it works, but still there is some problem. So when you executed this, it actually outputted, right? It dropped the stored hash column and then outputted. But when you try to see the actual data frame columns, there is an attribute called columns. Stored hash is still present even though you dropped. This happened because we haven't used in place true. An attribute called in place is there, and by default it is false. So this is for our convenience. If you by mistake execute drop method, you may have to execute all statement again to load the data, right? So if you want to really remove the column, you need to specify in place is equal to true. That will actually remove the column from the data set. So when your statement executed and the column got removed, the output is not going to be shown. You are seeing the output, that means the effect is not happened physically on the data frame. So let us see the columns now. See that the stored hash column got dropped. So that's how you need to drop the column. If you want to drop a row also, you can pass the index here and axis is equal to 0, or even if you don't specify axis, that works. So now if you see head, right, there is no stored column, and mean I think we have already seen. Right, on a data frame you can use mean method, which actually calculates all the numerical columns means. You have std, mode, median, all those methods are present here, like in series object. And now there is another method called group by. What is group by? Here in the data set we have 10 rows belonging to St. Mary's College and 10 rows belonging to St. Xavier College. So if you want to see the averages of the students from St. Mary's and St. Xavier, we can actually group by college, right, and then say mean. See that St. Xavier's mean is 6.5 on the quiz 1, 7.3 on the quiz 2, and St. Mary's is high in quiz 1 but low on quiz 2. See, with a simple method we can actually understand or do some data analysis here. Okay, so we can actually look at the size also. If you say size, it gives you how many records belonging to a given college or given categorical column. We call this college column as categorical column because there are only two categories: St. Xavier's College and St. Mary's College. If you can count the values in a particular column are discrete, then you call that column as categorical column. Okay. So if you want to group by a particular data frame, you definitely need to pass a categorical column, and then you can do aggregate functions like mean, right? The standard deviation, size, all those aggregate functions you can call. So that is about group by. And if you want to expand or explore group by, what is the outcome of group by, and then see what is happening there, you may have to loop like this. Let us try to see when you do only group by, it actually gives you a group by data frame group by object. But if you want to explore it, you may have to actually do a loop like this. See that? Group 1, the value is present in there. Group 2, the value is present in there. So that's how you can actually play with the data frame and do some analysis. And this is a very powerful tool like SQL queries. You can do many filterings and group bys and other stuff. So let us try to understand a little more about handling nulls in data frame, because quite often in data sets we'll have nulls and we need to curate them or impute them with some value there, some appropriate value in there. So before we impute or replace nulls with some other thing, we need to find those places where the nulls are present. So let us take a simple example, simple data set, and try to work with this. So I have taken a data frame with 1, 2, 3, 4 columns. So 4 rows, sorry, 4 rows. So I have created a list of lists. So in a list, I have given 4 lists. So that means 4 rows, and columns are 1, 2, and 3. When I execute this, I will get a data frame like this. Okay. In this, right, third row has got all nulls. In the first column, second column, there are one null, and third column, only one null there. Okay, 2 nulls and 1 null there. If you want to see where exactly nulls are present, either in rows or columns, you can use is null, is null and any method. Let us see what happens when you say is null. df underscore na dot is null will show you whether it is true or false. Okay, but in data frame we have got a method called any. Right? On is null, if you call any one value is null, it will actually output. If you give axis is equal to 0, it actually gives you in the first column we have null, in the second column we have null, third column also we have null. We don't know how many nulls. It is just showing you that there is a null present in each of the columns there. If you give 1 there, it will say in the first row there are no nulls, in the second row there is null, third row there is null, fourth row also there is null. We don't know how many. So if you say axis is equal to 1, I said it is columns, right? So here it is it is looking at all columns. When you say axis is equal to 1, all columns, that means row 1, row 2, row 3, row 4, like that. If I say axis 0, that is rows, right? All rows. If you look at all rows at once, it will give you columns, right? Whether there is all rows are nulls or not, any row is null or not, right? If I use any method, it will see any value is null or not. If I use all method, it will give you all or null or not. If you see this, there is a method called all also. If I say all axis is equal to 1, in any given row, there are all nulls or not. So see this, row 3, all nulls, right? If I say 0, it will give 1 false, 2 false, and 3 false, because in all 3 columns, not all values are nulls. See that? So it is looking at all the rows at once, and trying to see whether this method, whatever method you are using, is satisfying the condition or not. Okay, and then to drop values, you can say np dot the drop na. We have seen the output here also. In this method we have got in place true. If you put in place true, we will drop, the drop will be physically updated to the data frame. So I am not using in place true here. because I want to do some more experimentation. So drop NA will drop all the rows where nulls are present. Generally, we will not do this in our data science practice or the machine learning practice, because data is very precious. There may be one column with most of the values, 95% of the values are nulls. If you apply drop NA on a data frame, 95% of the data is going to be gone. So you cannot actually do any analysis or bring out any insights from the data. So data is very precious. So we'll never use drop NA, but for experimental purposes we are seeing. Okay. So you can specify how all or any. If you put any here, it's going to drop all the all the rows which have got at least one null. If you say all, right, it is going to drop only the rows with all nulls. So here the fourth row has got all nulls, so it actually dropped the fourth row. We can actually fill NA, or imputation we call it as. Fill NA with one number. If I say fill NA, right, if you use in place true, it's going to be physically updated. When you are seeing a data frame's outcome on the console, that means the physical update did not happen. So if you here also fill NA, it is actually showing you how it happened. If you use in place true, it will actually physically get updated. I am not going to do that because I have to do some more experimentation here. You can actually update a given column with a particular value. So first column I wanted to update 33, second column 66, and third column 99. So here I passed a dictionary with the column name and value to fill NA. So it actually filled the first column, it filled 33, second column 66, third column 99. Like that you can actually play with the nulls and fill the nulls. Now let us try to understand a little more about data frames on how to merge columns and how to map and add new columns. Okay, so I have taken a new data set, right? I have taken some data with a dictionary with key value pairs. The key is the city or the column name. City and population are the column names, and the values are the city names and the populations. Alma, Bryan, and Fox Park are the cities, and the populations are like this. And then I am creating a data frame with that. So let us see what happens. So it is a city and population, 2-column data set. And then I am actually trying to create a new column state in the data frame by mapping the city. So if I know the city state map like this, a dictionary, right? A city that belongs to Colorado, a city that belongs to Utah, a city that belongs to Wyoming, right? If I know the dictionary with the key value pairs, I can actually use that to map to the city. So in the city frame, I have a city column. So I am using that city column and mapping the dictionary. So it is going to look at the first row city and map it to the state, right? And the second row city and map it to the state, third row city and map it to the state. Let us see what happens when I execute this. See this? It is actually outputting Colorado, Utah, and Wyoming. This is actually a new series object it actually outputted. Let us see the type of it. See that? It's a series object. So in a data frame, I said each column is a series object. If you want to create a new column with state and then corresponding city state only should be populated, we can use this method, map. Okay. So let us try to see how can we use that map method and the dictionary and create a new column. To create a new column, we can take the data frame and give the name of the column. If the column is not present, right, it's going to get created. So city, city frame of city dot map, which actually gives you a series object, and we have assigned it to the data frame. So it created a state column. So that's how you can create a new column by mapping the values. A particular column has got a value and you want to create another column which is related to this column. You can do that by using map method. There is apply method also. We'll see that in while playing with the data sets, where there is an apply method and lambda methods can be used and all that stuff. We'll see that in the coming classes. So the next thing is how to concatenate or merge data frames. So here I have taken altitude, a new data frame. Now city and altitude, I have got another data frame. It's kind of a table. So if I want to concatenate the city frame and altitude frame, we can actually use pd.concat, and I have specified axis is equal to 1 because I want to concatenate column wise, and join is inner. When I specify join is inner, it's going to find the same named columns and try to join the data frame. See that it actually joined it, and it actually combined both the columns. If you want to create only altitude column in city frame, not all the columns you want to concatenate like this, you have to actually do it like this: city frame, and then specify the columns. In the city is the column which is present in there, and altitude is not present in the city frame. So altitude, the column is present in the altitude frame. If you try to equate like this, it is going to join on city and then create altitude column. See that? It actually joined on city and then created altitude column. So that's how you can actually merge, and there are more methods present in pandas API. So pandas data frame, to type like this, you will get the API. In there we have got all these methods to join and play with the data. Okay. So the last thing I would like to explain is how to access a particular cell value in a data frame. What I mean by cell is, in this data frame, if I want to access only this U tab, how to do that? So let us try to understand the difference between ILOC and LOC. ILOC generally counts the index. In this data frame we have got 0, 1, 2, right? If I remove this particular row, what happens? I'll have only 0 and 2 as indexes. But if you use ILOC, it will not look at the physical index in the data frame. It will actually count the records 0, 1, 2 like that, and try to extract the value where that particular number is present. Let us see. In city frame, ILOC of 1 will give you 0 and 1. The brain, this record it will give. Okay. So if you say LOC, it will also give the same thing because the physical index and the count are same here. But if I drop the first row, the second row, right? If I drop this second row and see how ILOC and LOC are working, you will understand the difference. See this, I am dropping the first row. So drop and index I passed and axis 0 I specified. Even if I specify it or not, it's going to work. I said in place true. That's going to be physically applied. And I have dropped it. Right. Let us see how the data frame is. Right. City frame. Right. I have got only 2 rows now. If I say ILOC, it's going to give me this Foxpark record, because ILOC always counts 0, 1. It counted and it found 1. And it outputted Foxpark. But LOC actually looks into the physical index. So there is no physical 1 index in there. It's going to throw error. See that? So the error 1 is not present there. So during handling the above exception, some mischievous error it throws, right? So LOC actually looks into the physical index. So now if you want to update a particular cell, you always should use LOC only. ILOC will not work. Okay. Now if you want to access a value at the second row index and the altitude, you need to pass it to the LOC like this in rectangular brackets. So it's going to be 2762, right? 2762, right? If you want to update it to 3333, you need to actually pass it like this, and then you can see that. Okay. But if you use ILOC, it's going to throw error. Okay, ILOC will not work. Okay, so LOC works. So you can actually do slicing also on this LOC, and we will see that more complex operations on data frames while playing with the datasets. Thank you very much.